Hello, ma'am.
ಕೇಳಿಸ್ತಾ ಇಲ್ವಾ? ಓಕೆ, ಕೇಳಿಸ್ತಾ ಇದೆಯಾ ಈಗ? ಏಬಲ್ ಟು ಹಿಯರ್?
Yes, ma'am. Yes, ma'am. Now,
Yeah, fine. Thank you, Ravi. Okay, so we'll start today with math functions. So functions available in SQL are SQL provides a large collection of inbuilt functions called as a also called library function that can be used directly in SQL. That is mathematical function, string function, date and time function. So first we'll see about a mathematical function. What is this mathematical function? Some of the commonly used mathematical functions are sum. It is one built-in function sum, or average, one more built-in function, or I want to count how many people have written DBMS, then we may use a count function, or I may use a min function, minimum of the value, or I may use a maximum. So like this, we may use a built-in functions. The same way, select some marks from student, or I may use a select minimum roll number or max marks from a student. So we may use some built-in functions like this, and we can calculate that. The same way, we have some more functions called as a string function. These functions are used to deal with the string type value like ASCII, lower, upper, length, left, right, trim, left trim, right trim. So then what is this ASCII character? I want to know what is the ASCII value of small a, or I want to know what is the ASCII character of capital A. Yes, we can do it. These are the built-in functions. In the same way, ASCII, what is the value of ASCII character of 1? So like this, we can use, this is what is a built-in function. So now, I have a lowercase. I want to convert from uppercase to lowercase. Then we use a built-in function called as a lower, and within that function, we have to pass a what is the string which you want to convert from a lowercase to uppercase. So this is what is called as a string function. Then the upper convert character strings data into uppercase. That is upper and a string. So you can see the string, whatever is there, that will be converted to a capital string function. So I want to know what is the length of the string. Returns the length of the character string, that is length, that is string. So I want to know what is the length of this string function. So it will be returns 50. So then string function replaces all occurrence of the second string, that is string 2 in the string 1 with the third string. Then replace, so I want to replace a string 1, string 2 or string 3. I can use that when we use the function called as a replace. So then we want to return only the left part of the string. Then you can specify a left built-in function called as a left, and specify the string from which you want only the left part, and you can specify what is the complete string size you want. So that's what here you can see this example, left, select left string function, and the size what we want, how many characters we want only 6. So when this function is executed, you will get it will return a string. So we have a built-in function as a write. Now I want to fetch the right part of the string, and what is the size of that particular string? Then we use that as a 8. So in the same way, string function, so left trim returns a string after removing leading blanks on left side. Remove left side space or blank. So then we can use a left trim. So select left trim string function returns a string. So then string function returns a string after removing leading blanks on right side. Remove right side space or a blank. So that's what right trim. So string function returns a string. So the same way, I want to reverse a particular string. Then you can use a reverse, and what string you want to reverse, you can give within that quotes. So that we have a replicate. Replicate, sometimes I want to repeat the same thing 3 times. Something like you want to repeat this statement 5 times. So then we can use a replicate function. And you specify how many times you want So that's what here it is a 3 times. That is function and 3 times. So the same way, string function, that is a space, returns a string of repeated space. That is space function is an equivalent of using replicate. So in the earlier, you can see here, because we know it is a function and there is no space between this function, then we say this is repeated 3 times. So this is not, we may not know whether is how to read this, because there is no space and we don't know whether it is a single complete word or it is a break. So then that's what here in this case we use a space function. So space returns a string of a repeated space. The space function is an equivalent of using replicate function to repeat space. Space, then integer, select string plus space plus function. That's what here string function. So then we use a string function, substring, returns part of a given string. So substring, so you can say a complete string is there, in that I just want only 5 characters. So then you can use a built-in function called as a substring. So what is the substring will be doing? It will give us where is a starting date, where is a starting index, and what is the length we want. So in that case, the length also you can specify. That's how you can take the substring. So just take an example here. So in this substring, so what we have done is select substring, string function 1,6. So then we have a string. Then select substring, string function 8,8. Then returns a function. So that's what here a string function substring will be done. So then we move on to the next command called as a delete command. So delete from table where condition. So delete from student where city equal to Chennai. So I want a student who is from Chennai to be deleted from the table called as a student. Yes, we can execute this. Similarly, it is not only, this is one small example where we are trying to delete a student where city is a Chennai. And now I want to update. So update the command, to update the data stored in the database, update command is used. That is update student set marks equals to marks plus 100, increase marks of all the students by 100, update student set city equals to Hyderabad where city equals to Bangalore. Change the city of those students to Hyderabad whose city is in Bangalore. So like this, we can update the columns which are there in the student table. So in the earlier example, we have just seen about updating only one column. So in case if I want to update multiple columns, then we can do like this. So update student set. So what we are doing, already we have some marks. For that we are adding again 20 extra marks to this. Something like you have written IA marks and we are adding assignment marks. So marks plus 20. For all students, I am giving a 20. So add that to IA marks. Then city equals to Bangalore, where city not in Delhi or Mysore. So we want to know other than Delhi and Mysore. So where city, we have to check each of them where Delhi, it should not be in Delhi and Mysore, and that particular city should be in a Bangalore. So that should be replaced. Other than Delhi and Mysore, wherever we have other values should be replaced to a Bangalore. Next, we move on creating a view. So what is this view? In SQL, we can create a view of already existing table that contains specific attributes of the table. Example, the table student that we created contains following fields: student, roll number, comma name, comma marks, comma class and city. So we can create a view like this where already table will be existing. So then how to do that? A small example, create view. So what is a student? 5th sem student as select roll number, name, class, from which table? Already table called as a student is existing. Then select star from 5th sem student. So the above command create a virtual table, that is a view named V student that has 3 attributes as mentioned, and all the rows under those attributes are as in the student table. So you can see here create view fifth sem students as select roll number, name, class from a student, where city not in Delhi. So we can try whichever data we want to be viewed, we can use. Then we should know what is the main difference between the view and the table. So the main difference between the table and the view is that the table is a repository of data. The table resides physically in the database. A view is not a part of the database physically representation. It is created on a table or another view. It is pre-compiled so that data retrieval becomes faster and also provides a secure accessibility mechanism. That's what a create view command is. The same way, alter table. So now already some data is there, but I want to alter that particular thing. In SQL, if we ever need to change the structure of the database, then alter table command is used. By using this command, we can add a column in the existing table, delete a column from a table or modify column in a table. Adding a column, the syntax to add a column is alter table, table name, add column name, data type. That's what your roll number, name, class, marks, and city. So now this is a table. For this table, I want to add one more column. Suppose let me say I want to add an address column. So then how to add that? Then we have a command called as a alter table, student, add address, and to that is a varchar. So what's the data type of the address? That is a varchar. Then you can say select star from student. So when you know, so this is how the address column will be added to the table, existing table. So here in this, but because we have added extra column, but the data will not be filled here. If we want data to be filled, then we have to use a command called as a update. So then alter table command, removing a column, alter table name. So I want to remove now. I have added a address column, but I want to remove that. Then alter table student, drop column address. So that's how we can alter the table. So sometimes you may need to drop a table which is not in use. Drop table command is used to delete and drop a table permanently. So drop table student. Now we move on referential integrity options. We can specify restriction and cascade, set null or set default on referential integrity constraint, that is a foreign key. Create table department, so department name, that is varchar 10 not null, d number, that is integer not null, manager SSN character 9, manager start date, that is character, then primary key d number, then unique d name, foreign key, so references employee on delete, set default on update cascade. That's how here referential integrity options will be used. So in the same way, some more referential integrity options: create table employee, employee name varchar 30 not null, so employee SSN character 9, birth date date, d number integer and default 1, super SSN character 9, primary key ESSN, that is employee social security number, then foreign key d number reference department on delete, set default on update cascade, then foreign key super SSN refers employee. So if we delete some primary key table, then what it should happen? So if you delete that, it should be updated. So now just take one database, complete database, that is a employee database. So in this case, you can see, so the employee company database, in this how many tables we have? We have a employee, department, department location, project, works on, and dependents. So the employee table, so the employee table, what are the columns we have? We have first name, middle name, last name, social security number, birth date, address, whether male or a female, the salary, then who is the head for that particular, whether he is the employee is a head or just an employee, That's what the super SSN. Then department number, for which department he is working. These are the details. Again, in this we are taking a SSN as a primary key. Then department, D name, D number, manager SSN, and manager start date. So here in this case, in department, what we are doing, we are taking a primary key, that is D number as a primary key. So in the same way, department location. So if we say you are coming for the first time to BMSIT college and you want to know where is MCA department, then what you will say, you will suggest them go to the BSN block and go for the second floor. Then you will be in a MCA department. Same way here, the department location cannot have a unique thing. Then this department number and D location put together is called as a candidate key. Then a project. The project is P name, P number, P location, and D number. That's what your project is. Then works on ESSN, P number, that is employee social security number, project number, then works on. That's what is works on is. Then dependent. So until unless any person is working for a particular company, then we cannot have a table called as a dependent. So in the dependent table, what we have, social SSN, employee social security number, department name, whether male or a female, birth date, and the relationship. That's what here is a company database. So then what are the values we have in the company database? So the first one is a employee table. So in the employee table, we have seen the first name, middle name, last name, all these are the values. So now in this, John B. Smith is an employee. What is his social security number? This is a social security number. What is his birth date? This is what the birth date is. What is the address of that particular employee? This is what the address is. Whether a male or a female, and what is his salary? Whether he is working for any department. If he is working, who is his manager? That's what your manager number. And for which department he is working? He is working for 5. So like this, other details of all the employees are here. Yes, this is a employee table. Next is a department table. In the department, how many departments are there? There are 3 departments. One is research, administration, and a headquarter. The research is 5, administration is 4, headquarter is 1. So these are the different departments where department numbers are there. Then manager SSN, manager social security number, then manager start date. So these are the which date they have started. Then department location, that is D number and the location. So these are 1, 4, 5, all these. Then these are the numbers, and these are the locations where we take. Then works on, where they are working on. That is employee social security number, what is the project number, and what are the hours. So that's how here works on table we are doing. Then project, so that is a product XYZ, for what is a project title, that is X project, Y project, and Z project. And computerization, what is the other one, that reorganization and the new benefits. Then we have a project number 1, 2, 3, and 10, 20, and 30. Then location, these are the locations, and what are the numbers where the D number are. Then the dependents, so these are the dependent table. First, the employee should be working in a particular company, and that's what the, so employees details. Then dependent name, what is a dependent name? What is the, whether male or a female, then birth date, and the relationship. That's how here dependents we are taking. So next we move on to a simple SQL queries. So now the same in the board table, what did we do? So we have just created a table, but we want to retrieve the birth date and the address of the employee whose name is John B. Smith. So in that case, how do we write? So in the relational algebra, so how did we write? We have used a pi select keyword, select symbols. So whereas in the SQL, we are using combined select as well as project. So how do we write? Select what they asked in the query. What is a question? What is a query question? Retrieve the birth date. So then we should say select birth date. And address. So address also should be taken. From which table? From employee table, where first name equal to John and middle name is B and the last name is Smith. So that's how we take it as a simple query on one relation. That's what a select and project. Then retrieve the name and address of all the employee who work for the research department. That is, select first name, last name, address from the employee department where department name is research, and the department number in the employee table and the department number in the department table should be matching. So here what did we do? We have used a join operator. So not only select and project, along with select and project, we have used a join operator, which we have used in a relational algebra. So what are the join operators we have used? We can see here D name equal to research. That is one join operator. In the same way, one more join operator is D number equals to D number. We are comparing two tables. One is employee and department, and we are taking the values from both the tables. In that case, we are joining. We want to know the employee who is working for the research and his department should be same in employee table and the department table. That's how here the join operator is used, select and projector is used. So for every project, for every project located in Stanford, list the project number, the controlling department number, and the department manager's last name, address, and birth date. So that's what here simple SQL query is. So select P number, D number, last name, birth date, address from a project, department, employee where D number equals to D number and manager SSN is equal to SSN and location equals to Stanford. So these are the two join operators where we are using. The join condition is D number equals to D number, and the join conditions are manager SSN is equal to SSN. That's how here we are using a two join operator, that is D number equals to D number and manager SSN is equal to SSN. That's what a simple SQL query is being used. So now we use a alias. So why do we use alias? Now you have your name. So in your register, you may have some name, but in your home, if your parents may be giving, we would have been calling you by your pet names. So the same way here, alias is other name given to the table, that is employee dot last name and department dot D name. So alias, so let us see for each employee, retrieve the employee's name and the name of his or her immediate supervisor. Select employee first name, employee last name, supervisor's first name, supervisor's last name from employee E and S, where E dot super SSN equal to S dot super SSN. So in this case, what we are doing in the alternate relation names E and S are called aliases or tuple variable for the employee relation. We can think of E and S as two different copies of employees. E is one copy and S is another copy. That's what here alias means. We are giving the same employee table has a two copies. One we are calling with the E and another we are calling with the S. Okay, same alias can be called using the as. So select employees, that is employee as E. Either you can call the employee as E or you can call employee as S. So that's what here, select E dot F name, E dot first name, E dot last name, then S dot first name and S dot last name from employee as E, employee as S, where E dot super SSN equals to S dot SSN. That's what here alias will be done. So unspecified where clause. So sometimes we don't want to use a condition. We just want all the columns from the employee table where select only the SSN. Select SSN from the employee table. If more than one relation is specified in the from clause and there is no join condition, then the Cartesian product of tuple is selected. So select SSN D name from employee and department. It is extremely important while specifying any selection and join conditions in the where clause. Otherwise, incorrect and very large results may be relations may be resulted. So Now we are using a star operator. So why do we use a star? So select star from employee where D number equal to 5. So what we are doing, a star is used to represent that I want all values in the table. Then we use star. From which table? From employee table. And which rows we want? Those rows where the D number is 5. In the same way, select star from employee department where D name equal to research and D number equals to D number. So that's what here use of star is. That is, select star from employee department where D name equal to research and D number equals to D number. That is the use of star. Then we use one more keyword called as a distinct. So what is this distinct we are using? SQL does not treat a relation as a set and duplicate values can appear. So to eliminate the duplicate tuples in the query result, the keyword distinct is used. Suppose let me say that, so the employees, there are some 50 employees in the company. And in 50 employees, 30 employees have their salary as 40,000. So then how many times we repeat their salary 40,000? 30 times. Because all 30 employees are having their salary as 40,000, 40, 40, 40, 40, like this. How many? For 30 employees we take. So instead of that, if we use a distinct, all 30 will be having 40, but it will be having only one time. Instead of repeating, it will be done for only one time. For example, the result of question 11. So what we have done in the earlier, select salary from employee, then select distinct salary. Distinct means unique. Select distinct unique salary from the employee table. Okay, so then we have a set operation, that is SQL has directly incorporated some set operation. There is a union operation, that is union, and in some versions of SQL there are a set difference, that is minus, and intersection operation also. The resulting relation of these set operations are set of tuples. So duplicate tuples are eliminated from the result. The set operations may apply on union compactable relation. The two relation must have the same attribute and the attribute must be appearing in the order. So then let us see what is a set operation. Make a list of all project number of a projects that involve an employee whose last name is Smith as the worker or as a manager of the department that controls the project. So select project name from project department employee where D number equals to D number and manager SSN is equal to SSN and last name equal to Smith union. Select project name from project works on employee where project number equals to P number and employee social security number is equal to social security number and the name is a Smith. So because they have given in the query saying that whose last name is Smith. So and they have told here we are using a union operator. So using that we are able to do this set operation. Next we move on to a nesting of queries. A complete select query called a nested query can be specified within the where clause of another query called the outer query. Many of the previous queries can be specified in an alternative form using nesting. So retrieve the name and address of all the employees who work for the research department. That is, select first name, last name, address from employee where D number in select D number from department where D name equal to research. So the green color one query will be executed first. After this inner query is executed, the outer query will be executed. That is what is a nesting of query. So then nesting of query, the nested query selects the number of research department. The outer query selects the employee tuple. If it is D number value is in the result of either a nested query, the comparison operator in compares a value V with a set or a multi-set of values v and evaluates to true if v is one of the elements in v. In general, we can see we can have several levels of nested queries. A reference to an unqualified attribute refers to the relation declared in the innermost nested query. In this example, the nested query is most correlated with the outer query. So how do we say a correlated nested queries? If the condition, if a condition in the where clause of a nested query reference an attribute of a relation declared in the outer query, the two queries are said to be correlated. The result of the correlated nested query is different for each tuple of the relation, the outer query. So retrieve the name of each employee who has a dependent with the same first name as the employee. So now you can see, select first name, employee's first name, employee's last name. From which table? From employee's table. And we are using it as means alias to the same table called as a E, where what we want, where the employee social security number should be there in the dependent table. Along with that, the employee social security number in the employee table and employee social security number in the dependent table should be matching, and the first name of the employee should be same as dependent name. So now you can see if both parents' name starts with SS, even they feel that their kid's name should also start with S, something like that. That's what this query is, similar to that one. So query written with the nested select from where block and using the in equal to or in comparison operator can always be expressed as a single block query. For example, question number 12, what we have seen earlier, can be rewritten as, so instead of using a nested queries, correlated queries, we can directly write something like this. So what we can write is, so we can write select first name, employee last name from employee E dependent D, where ESSN equals to department ESSN, that is employees SSN should be equal to dependent SSN, and employee's first name should be equals to dependent name. So that's what here, this is how we are using it as a nested queries. So in the same way, correlated nested queries retrieve the name of each employee who works on all the projects controlled by the department number 5. Select first name, last name from employee, where select project number from works on, where SSN equals to ESSN contains select P number from project, where D number equals to 5. That is what is a correlated nested query. So then we have to use a exist function. I want to know whether Ramesh is there in the third semester class or not. How to know? I have to check all your 51 students' names and verify whether the Ramesh is there or not. So the same way here, retrieve the name of each employee who has dependent with the same first name as the employee. I want to know whether name of the employee, suppose let us take Ramesh, Ramesh is his first name, and we want to know whether his kid's name also starts with Ramesh. So that's what here, and compare that, and we want to select that particular person's name. So then select first name, last name from employee, where exists select star from dependent, where SSN equals to ESSN and first name equals to dependent name. That's what here we use a exist function. Retrieve the name of each employee who has dependent with the same first name as the employee table. Then we move on a exist function. So where we have used a exist function, now we use a not exist function. Select first name, last name from employee, where not exist, select star from dependent, where SSN equals to SSN. So that's what here you can see, not exist we have used. So not exist query can be used. In the same way, now we use a explicit function. It is also possible to use an explicit, that is a enumerated set of values in the where clause. Rather than nesting a query, retrieve the social security number of all the employee who work on project number 1, 2 or 3. So then we can say select distinct employees SSN from works on where project number in 1, 2, 3. In the same way, I want to know nulls in the SQL query. So SQL allow queries that check if a value is null or missing or undefined or not applicable. So in that case, when do we use a null? When I don't know the value. Suppose now I don't know all your 51 students' phone numbers. Then I say null. So what are the cases when I say null? So that's what here is given. SQL uses is or is not to compare nulls, because it is considered each null value distinct from other null values. So equality comparison is not appropriate. Retrieve the names of all employees who do not have a supervisor. Select first name, last name from employee where super SSN is a null. So that's what here the null is being used. So in the same way, you can use a join operator or a join relation feature. Can specify a join relation in the from clause. Looks like any other relation but is the result of a join. Allows the user to specify different types of join, that is a theta join, natural join, left outer join, a right outer join, cross join. So then select first name, last name of the employees, supervisor first name and the last name from our employee table, where the copy of the employee is in S as well as copy is present in the S also, where employee super SSN should be matching with the supervisor's SSN. So the same query can be written using a left outer join. So how we can write? So we can write select first name of the employee, last name of the employee, and supervisor's first name, supervisor's last name from employee E, left outer join employees on E dot super SSN equal to S dot super SSN. That is what here join can be used, the left outer join. In the same way, the same query we can see here how can we use with the different joins. So the select first name, last name, address from the employee table as well as from the department table, where department name should be equal to research and department number should be equal to department number. Then how should we write? Then select first name, last name, address from employee, join department. How to join? What is the condition we are joining employee and a department? We are joining based on the D number. So D number should be equal to D number, where department name should be equal to research. Select first name, last name, address from employee, that is a natural join, department as department name, D number, manager assistant, manager date, where D name equals to research. That's what here join relation feature works. So let us take one more example. Another example where I want to select a project number, D number, last name, birth date, address from project, then join department on D number equals to D number, join employee on manager SSN equals to SSN, where location equals to Stanford. So this is how you can use a join. So next we start with the aggregate function in the next class, that is tomorrow first hour class. Now I'll stop and so we'll continue in the next class. Anterior attendants, Asta, Abhinav, Aishwarya, Ambrish,
Present, ma'am.
Ambrish, Anu,
Present, ma'am.
Arbaz,
Ma'am.
Arjun,
Present, ma'am.
Ashok,
Ma'am, Amrish present.
Marked Ambrish, Benita,
Present, ma'am.
Bhargavi, Pavishya,
Present, ma'am.
Chaitra,
Present, ma'am.
Demalai,
Present, ma'am.
Diksha,
Present, ma'am.
Deepika, LG,
Present, ma'am. Present, ma'am.
Deepika MB,
Present, ma'am.
Murli Krishna,
Present, ma'am.
Gangubai,
Present, ma'am.
Gujia,
Present, ma'am.
Harshit,
Present, ma'am.
Chunjar,
Present, ma'am.
Kavya,
Present, ma'am.
Kishore, Lata,
Yes, ma'am.
Manisha,
Present, ma'am.
Manjunath,
Yes, ma'am.
Nayana,
Present, ma'am.
Nilanjan, Nishant, Pavitra.
Present, ma'am.
Yesterday, madam.
Ma'am, my speaker was not able to ma'am, to answer.
Maithili,
Present, ma'am.
Priyanka,
Present, ma'am.
Pavan,
Present, ma'am.
Akash,
Present, ma'am.
Rajeshwari,
Present, ma'am.
Rakesh,
Present, ma'am.
Ramya,
Present, ma'am.
Rashmi,
Present, ma'am.
Ravi,
Yes, ma'am.
Rizwan,
Present, ma'am.
Vishal,
Present, ma'am.
Savita.
Ma'am.
Yesterday, madam. Shruti,
Present, ma'am.
yesterday.
Present, ma'am.
Sneha,
Yes, ma'am.
Spurti,
Present, ma'am.
Srinidhi, Srinivas,
Present, ma'am.
Sunil,
Present, ma'am.
Vaishnavi,
Present, ma'am.
Vinny.
Present, ma'am.
Okay, so I'll wait for 2 or 3 minutes to complete your quiz.
Ma'am, BY29 present, ma'am.
Nilanjan, you will not answer. You will answer only at the end. Marked. Okay, so 2 minutes I'll wait for you people to complete your quiz. So I'll repaste the quiz link. You can complete the quiz. Okay. So we'll see you tomorrow's class.